Good morning, class, and welcome to Unit 4, Lesson 4, Day 2. So we are going to continue to solve exponential and logarithmic equations today. So we're first going to look at an example similar to one we looked at yesterday. I see that there is an e to the 2x and then an e to the x. We should start to see that this is similar to this problem. X squared minus 5x minus 24. Okay, so how do we handle this one? Well, this one we would just factor. We would say what multiplies to a negative 24 but adds to negative 5. Well, what would that be? Negative 8 and 3? Yeah. So the difference is instead of having an x squared, it's really an e to the x squared. Okay, so instead of writing x's in the front, I'm going to write e to the x. So, same idea. What multiplies to negative 24 but adds to negative 5? Negative 8 and 3. Then, when we were solving these, we would just take each one, set it equal to 0, and solve. So we're going to do that here. We have e to the x minus 8 equals 0, and e to the x plus 3 equals 0. So if I solve this, I have e to the x, if I add 8 to the other side, equals 8. And then in order to get rid of e, remember we ln on both sides. We like ln and e, they cancel each other out. You are just left with x is equal to the ln of 8. And then the directions say to round to 4 decimal places, so you would type in ln of 8 onto your calculator, and you would get 2.0794. Here, the other one I would solve, yes, and we're okay with plugging these in. It's logs. Remember that we have to worry about our domain. Can't take the log of negatives or 0. So here I would subtract 3. And then I would ln on both sides to get x by itself. So x is equal to ln of negative 3. If I try and type this into my calculator, it is going to say domain error. It's going to say error, no, non-real answer. Because in order to plug into here, you have to have numbers that are greater than 0. So basically only positives. So in this case, this provides us no information because our domain of ln of x is that x has to be greater than 0. So this gives us nothing. So our only answer here would be this one. Okay. So that is example 1. Example 1b now, we go ahead and we need to solve for x, and I see that, there's not an e to the x squared, I just have e to the x's. So what I would maybe do is say, can I factor those out? I'm looking for a GCF, so what would my GCF be? There's for sure an e to the x, and it looks like I can also take out an x. So I would have x, e to the x, and then in parentheses, what would I have left? 2 plus x equals 0. Now, we would set each part equal to 0. So I would have, it's really x would equal 0, e to the x would equal 0. These are two separate parts. And 2 plus x is equal to 0. And then we have to solve all three of these. Well, x equals 0. Would that work? If you plug this into your calculator, e to the 0. You plug in 0 for all your x's. Does it equal 0? Yes, it will. Okay, so this is one answer. Now the next one, we go ahead, we need to solve for x, so I would ln on both sides. These will cancel, so I'll have x equals ln of 0. If you type this into your calculator, once again, you are going to get non-real answers because you cannot plug in 0 to your natural log function. The domain for this is that x has to be greater than 0. Can't be negative, can't be 0. So that one gives us no information. And then the final one, to get x by itself, I would go ahead and subtract 2. So x equals negative 2. So is it okay to have a negative answer? Well, you can plug it in. So it's really going to be 2, negative 2, plus e to the negative 2. Not plus e, my bad. Times e. E to the negative 2. Plus negative 2 squared, e to the negative 2 equals 0. You could type this into your calculator to check. I'm going to just do it without my calculator. 2 times negative 2 is negative 4 e to the negative second. And then this is really negative 2 squared, so plus 4 e to the negative second equals 0. Are these two things going to cancel to be 0? They are like terms, so yes, they will. So 0 equals 0. So yes, x equals negative 2 is an answer. So I have two answers, x equals 0 and x equals negative 2 for that problem. Okay. 1C. All right, we need to go ahead and solve, and we did problems like this yesterday. The first goal is to isolate the part that has the exponent with the variable. Okay, so with that being, in this case, 2.8 to the 3x. I need to get that all the way by itself. So my first step would be to divide both sides by 5. So now I have 2.8 to the 3x is equal to 300. Now that it's by itself, I can log on both sides. So I'm going to go ahead and log on both sides. We like logs because it allows us to take what's up in the exponent and bring it down in front. So remember, you're putting it in front of the log. So I really have 3x log of 2.8 equals log of 300. And now I'm trying to get x by itself. It's 3 times x times log of 2.8, so I'm going to divide by what I want to get rid of. Log 2.8, 3 log. That all cancels. So x equals log of 300 divided by 3 log of 2.8. Now, why did I put it in parentheses? When you type this piece into your calculator, you need to make sure that's all in parentheses, and remember it provides you with this one, so make sure you end it. I would recommend typing this into your calculator on your own right now to make sure you can get the right answer. And when you do, as long as I did not make a mistake, it should be 1.8466. I have that written on a sheet, but let me confirm. Yes, that is correct. Okay, so that is our answer for 1C. 1D, I go ahead and I see this one. My first goal is to check, is the part that has the variable as an exponent, is it isolated? In this case, there's nothing in front, so yes, it is. So that means I can log on both sides. Okay, so I'm going to take my exponent and put it in front. It's really negative x over 100, so I'm going to write it as negative x over 100. Log of 5 equals log of 2. Okay. So let's go ahead. We see this as, we have divided by 100. Let's get rid of that. Get rid of our fraction. So I'm going to times both sides by 100. So I really have negative x log of 5 is equal to. Now, it is log of 2. You do not take the 2 times the 100. It's 100 times the log of 2. Okay. The only way you can change this inside is if you would have had log of 2 plus log of 100. Then you can put them back together with our properties of multiplying, but that is not the case here. Okay. So now my goal is just to get x by itself. I am going to divide. I'm going to divide by log of 5, and I also want to get rid of my negative, so I'm going to divide by a negative log of 5. So these will cancel. So my answer is x equals 100 log of 2 minus log of 5. Or not log, minus, divided by log of 5. And then you type that one into your calculator. You should get, the answer is negative 43.0677. That would be your answer for example 1D. Okay. Now we just did exponentials. Now we're going to move on to log equations. So now yesterday we had it when we had just one log. Today we're going to have it when there is log actually on both sides. Your goal is to have one log on the left-hand side and one log on the right-hand side. And then it's actually pretty easy. The logs will eliminate, and you can just go ahead and solve for x. Okay? So this example, I see I have 2 logs on the left-hand side. So I have to remember my law of logs. My first law is that if we have log of A plus log of B, I can go ahead and rewrite it as log of A times B. The other rule is if I have log of A minus log of B, I can put those back together with division because it was subtraction. So it's A divided by B. So I look at this one. The left-hand side has addition, so I'm going to rewrite it with multiplication. And that will equal log of x plus 2. Once you rewrite it, then from here it's actually pretty easy. Do you see how they both have a log? And then they both have the insides. Well, in order to be equal, the logs will cancel out, and you can just say what's on the inside has to equal each other. So I have 4x minus 3 has to equal x plus 2. So I would distribute my 4. And then I'm going to solve for x. So I'm going to subtract this x to the other side. So I'll have 3x minus 12 equals 3. And then add 12 to the other side. And divide by 3. So I would have x is equal to 5. And if you wanted to, you could totally replug this back in and make sure it works. You could type it into your calculator, but we would have log of 5 minus 3. So 5 minus 3 would be 2. 2 times 4 is 8. So log of 8. Does log of 8 equal? Did I make a mistake on this one? Oh, yes, I did. Do you guys see my mistake? I was like, that actually doesn't work. So good thing I checked. I rewrote this wrong, didn't I? My bad. This should have stayed a 2. So then this would be still 2. If I add 2 to the other side, it's 14. So our answer is 14 over 3. There we go. That should be the right answer. Now if I plug 14 over 3 in here, it's a little bit more complicated of a problem. But if I do 14 divided by 3 on my calculator, minus 3 times 4, I get 6.6 repeating. 6.6 repeating. And then if I do 14 divided by 3 plus 2 on my calculator, I get 6.6 repeating. So the logs are the same on the inside. So yes, that is my x value. But you could use this method to check on your test. Okay, so make sure you do that. So here we go. We got to do the same thing. We're solving for x. Make each side have one log. So the left-hand side I see is separated with addition. So I'm going to rewrite it with multiplication. So it's 3 times x equals the right-hand side. It's 5 plus log base 2 of x minus 2. So it's really 5 times x minus 2. Now the logs, this is one thing I should have said, they have to be the same log base. So the back here, they are both log really base 10, so they would cancel. These are both log base 2s. And so these will cancel, and the insides will equal. So we have 3x is equal to 5x minus 2. We will distribute 5x minus 10. Then I will have, I'm going to subtract the 5x. So I'll have negative 2x equals negative 10. And then if I divide, x will equal 5. Okay. Same thing, you can plug it in here. 3 times 5 is 15. So I'd have 15, and then I'd have 5 minus 2 is 3, so 3 times 5 is 15 again. So both of them would be the same. You could actually even go to the original. You could type into your calculator, you guys know how to do this, log base 2 of 3 plus log base 2 of my x value, which is 5. And does that equal log base 2 of 5 plus log base 2 of, well, it's going to be log base 2 of 3. So yes, it should. Okay, so you can always check your answer, and I highly recommend that you do. Okay. B. Left-hand side, we have addition, so I'm going to rewrite it with multiplication. So it's 4x. The right-hand side, we have addition, so I'm going to rewrite it with multiplication again. Now I have one single log on each side. They can cancel each other out. So I will have 4x is equal to, I'm going to distribute right away, 6x plus 6. If I subtract 6x to the other side, I have negative 2x equals 6. And then when I divide, I go ahead and I have negative 3. Now that I have a negative, remember, I have to check. If I plug this in here, will it work? Can you take logs of negative numbers? No. So actually, this doesn't work. And so this is a no solution. Okay. All right. Moving on, 2C. 2C is a little different, okay? A few reasons. There's only logs on one side. So this is actually a problem like we did on our notes yesterday. First thing we have to do is make it one single log. Ooh, or an easier way You could make this a single log, or if I add this to the other side, let's do it that way. That might be easier. So you could rewrite it with division, or I could add this to the other side. So I have log base 2 of x squared minus 3x equals log base 2 of 10. The left-hand side has a log base 2, and the right-hand side has a log base 2, so those will cancel, and the insides have to equal each other. So now I will have x squared minus 3x equals 10. I see it's a quadratic, so I need to factor. So I subtract 10 to the other side. So I need to multiply to negative 10, but add to negative 5. Positive 2, negative 5. If I set each one of them equal to 0, I will get x equals negative 2 and x equals 5. Then I should always check to make sure it won't be a negative answer. So if I plug in a negative 2 here, I have negative 2 squared minus 3 times negative 2. So this would be 4 plus 6, which is 10. So that one's good. Let's go ahead and check if I plug in 5. I would have 5 squared minus 3 times 5 into this part. That's the part I'm worried, the inside of the log piece. 25 minus 15, which is 10. So actually they both work. Okay, so make sure you plug it in and check. All right, now D. There is no way to make it so I have a log on each side, so I am going to have to put this into exponential form. So I'm going to do my little swing move. So this is really a log base 10. So it's 10 to the third is equal to what's on the inside, 4x minus 6. 10 to the third is 1,000. If I add 6 to the other side, I'll have 1,006 equals 4x. And then if I divide both sides by 4, you should get 251.5 for our answer for that one. Okay, so that is example D. We have 2 your turn problems. I would recommend you pause the video and do this one. Okay. On your own, and then I'll come back and you can come back and we'll redo it. Okay. So hopefully you pause the video. Now on the left hand side I see there's 2 logs, so I'm going to rewrite it with multiplication. So it's really x times x minus 2 equals the right hand side. Now that the left hand side only has 1 log and the right hand side only has 1 log, I can set the insides equal, so I'll have x squared minus 2x is equal to 3x plus 6. I see it's a quadratic, so I am going to have to factor. So I get everything to one side. So I move the 3x over, move the 6 over. We factor. Multiplies to 6, negative 6, but adds to negative 5. So a common one would be negative 2 and negative 3. That would add to negative 5. However, that would multiply to a positive 6. So we got to do negative 6 and positive 1. Okay, so then I have x minus 6 equals 0. So x equals 6. X plus 1 equals 0, so x equals negative 1. Then we always check with our logs. This is a log of just x, so right away I know my negative is an out. If I plug in my 6, 6 minus 2 is 4, so it's positive. So that's good there. And then this would be positive. So x equals 6 would be a correct answer. Okay. All right. Example, or problem 2. I am going to go ahead and I could try and do what I did on this problem. However, do you guys see that there's random numbers in here? So this time it's not going to work. I'm not going to be able to just have a log on the left-hand side and a log on the right-hand side. So what we're going to do is we're going to put our logs together on one side and then put all of our numbers together on the other side. So these are being added, so we can rewrite it with multiplying. So it's going to be log of x times 3x plus 5 equals, and then I'm going to add this to the other side. So 2. Now, in order to get rid of the log, because there's only 1, we have to put it into exponential form, so our little swing move. So it's really 10 to the second is equal to the inside. So I would distribute, so I have 100 equals 3x squared plus 5x. And then I see it's a quadratic. So I got to get everybody to one side. And now I'm going to go ahead and factor. It's been a while since we factored these. So we know the front is going to have a 3x and an x because we have to multiply to 3x squared. And then our options for 100. We've got 1 and 100, 2 and 50, 4 and 25, 5 and 20, 10 and 10. Okay, so if I try 10 and 10, if I had no idea, I like to start with my ones that are closer, this would give me 10x, and this would give me 30x. No way I'm getting to 100, so that one's not, or sorry, no way we're getting to 5 with that one. So that's not going to work. Let's move on to 5 and 20. If I do 5 here and 20 here, this would give me 5x, and this would give me 60x. But what if I switched them? Shall we switch them? This was 20, and this was 5. This would give me 20x, and this would give me 15x. That would work. The 15x was negative, and this was positive. 20x minus 15x is 5x, so that's good. And then I go ahead and set each one equal to 0. So I would subtract 20 to the other side and divide by 3. So x is equal to negative 20 over 3. And here I would have x is equal to 5. Then we just need to check. Oh, there's this x here. So right away my negative's out. Then if I plug in 5, that would be positive, and then 3 times 5 is 15 plus 5, so that one's positive. So our only answer here would be x is equal to 5. Okay. So that is it for our notes for today. Your homework is the lesson 4.4 worksheet. So if you have any questions, feel free to ask me. Feel free to send me a Schoology message, or you can ask me tomorrow in class. Talk to you later. Have a good day.